Hello everyone, in this video I'm going to show you an overview of this section. The title of this section is a concrete beam under a bending condition. What are you going to learn in this section? First video is going to be about modeling a concrete beam under bending conditions. So purely it's going to be concrete beam without any reinforcement. And we're going to use the analytical load cell to apply a displacement. And then in the second tutorial I'm going to show you how to reinforce a concrete beam with a composite layers laminate. And in the third video we're gonna reinforce a concrete beam with steel bars and strips, and finally in the last video we're gonna use a metal foam. And also this section has two assignments, which is the first assignment I'll ask you to use a different type of concrete, high performance concrete, and in the second assignment the idea is that you use the two type of reinforcement for the concrete beam. So the geometry we're going to have a beam with a length of 2 meters, and as you can see this is a cross section area with a rectangle profile is 150 millimeter width and the height of 200 millimeter, and also we have a hollow in the middle with a profile shape and with a rectangular shape, and the width is 90 millimeter and the height is 140 millimeter. So we're gonna start modeling by modeling a beam, and then we're gonna assemble it with analytical rigid bodies, and finally we are gonna apply a mesh. So this process is we're going to do this process for the first tutorial, and so it's quite important you don't jump the tutorials, so you start it from the first tutorial, because in the next tutorial we are going to just use the model that we created in the first tutorial, so we are not going to repeat this process again. And what we are expecting in the results section, so as you can see in concrete beam we're going to have a stress plot and also tensile damage, and when we have a CFRP then we're gonna have the stress and also damage, and also tensile damage on the CFRP layers as well. And here we have a concrete beam with the strips and bars, as you can see, and finally the metal foam. As you can see here, you can notice that when we add the reinforcement we will have a larger area under damage. For instance, if we compare concrete beam with the strips and bar to concrete beam, you can see that the damage is only here, but with a reinforcement the larger area goes under damage. To explain this we can use the load displacement plot. As you can see here, the black line is a concrete only. So when we add a reinforcement we have a very small improvement in maximum failure load that happens around 8,000 Newton. But when we have a concrete only, after reaching to maximum failure load we have a drop in the load, so we have a kind of like a full failure. But if you look at this one, that's why we have something like this in this section. But when we have a reinforcement, then those reinforcements will help a concrete beam to redistribute the load to the other parts of the beam. That's why the larger area goes under damage, and as you can see, when the area goes under damage we will have a more drop in the load displacement curve. Those shows the crack initiation. So we call this area a damage formation stage, and we call this area damage stabilization step. So this is what you can expect. So we're going to analyze the stress distribution, damage plot, and also load displacement. So now you can start this tutorial by starting a first video. I hope you enjoy this section.